Howdy! Welcome to Inspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video describes the properties of a standard normal distribution. Let's get started. Okay, the standard normal distribution is just like the normal distributions that we've seen in previous mini lectures, but there's a special caveat. It's a special type of normal distribution because it has a fixed value for the mean and the standard deviation. The mean value for the standard normal distribution is 0, and the standard deviation is 1. These two properties are pretty much standard for the standard normal distribution. So if you don't have a mean value of 0 and a standard deviation of 1, then you don't have a standard normal distribution. Now, the total area underneath the density curve is equal to 1. And it wouldn't be a density curve if that weren't true. So, yes, we have a continuous probability distribution here with that area underneath the density curve equal to 1. If you remember from previous mini lectures where we talked about z-scores, you should remember that the z-score is the distance that a given random variable is from the mean value. Well, when we have the standard normal distribution, because the standard deviation is equal to 1, that means this value here for 1 is actually a z-score of positive 1 because it resides 1 standard deviation away from the mean. Same thing here with the other side. This negative 1 here, that's 1 standard deviation to the left of the mean, and so this corresponds with a z-score of 1. So these random variable values for the standard normal distribution are really the same thing as z-scores. And this is one of the features that make the standard normal distribution one of the most useful tools in our statistics toolbox. So if we calculate the z-scores for a normal distribution, then we can actually convert that normal distribution into a standard normal distribution. Let's take a quick quiz to see if we can retain what it is we just learned about the properties of the standard normal distribution. So here we're given a distribution with a mean value of 0 and a standard deviation of 1. And we're asked to identify whether this distribution is a standard normal distribution. So what say you? Do we have the standard normal distribution here? Well, I hope you said yes. This is the standard normal distribution. A normal distribution, so it's got that bell shape to the curve, and it's got a mean value of 0, and it's got a standard deviation of 1. So those are the properties that make up the standard normal distribution. What about this distribution here? We've got a mean value of 1010 and a standard deviation of 20. So do we have a standard normal distribution here? What say you? Well, I hope you said no, we do not have a standard normal distribution because the mean value is not 0, the standard deviation is not 1. Those two features there are absolute requirements for the standard normal distribution. So if you've got some other mean value and or some other standard deviation value, then you do not have a standard normal distribution. So remember, this is the definition for a standard normal distribution. You must have that mean value of 0 and you must have the standard deviation equal to 1. So throughout this course, you're going to see in future mini lectures, we're going to keep coming back to this standard normal distribution. Okay? 3 main properties to the standard normal distribution. We have that bell-shaped density curve. So the graph is going to look like that standard bell shape that's symmetrical on either side of that central axis. The mean value will be equal to 0, and the standard deviation will be equal to 1. So when you have a normal distribution, you're going to have the bell shape to the curve. But if you also have the mean value equal to 0 and the standard deviation equal to 1, you're going to have the particular brand of normal distribution that we call the standard normal distribution. That means the area under the curve is going to represent probabilities associated with the bound. So we get some certain z-score that comes out, and then we want to know which side of the z-score we're on, and so we're going to get the probability less than that, the probability greater than that, and then that area underneath the curve is going to give us the probability that we're looking for. So the bounds of that area are going to correspond to z-scores, like I just said. And then we get we find the area that's bounded by that z-score, and that's going to give us our probability. So z-scores give us the bounds for the area under the curve, which gives us the area under the curve, which gives us associated probability. But we can go the other way as well. We start out with a probability that gives us a certain area under the curve. That area will be bounded, and the bounds of that area will then give us a z-score. So we can go either way. We can start with the z-score and get the probability, or we can start with the probability and get the z-score. That brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.